Welcome to Stoichiometry Part 2, requested by Jeffrey and Patrick. We have two questions in this video. The first one is the one we did in Mr. Benson's class because Patrick wanted me to go over this again, and the second one is just one from the work packet that Mr. Benson gave us. So we'll start with the first one. A 10.00 gram impure sample of chromium reacted with excess lithium sulfide and produced 1.75 grams of the metal. What is the percent purity of the chromium if chromium forms a +2 ion? So at the start of each stoichiometry question, we always have to write out a balanced equation. So chromium reacts with lithium sulfide. So, right, Cr. Let me just zoom in a little. Cr. And then plus lithium. 1 second. Lithium sulfide. Lithium is a +1 ion and sulfide is +2, so we need 2 lithiums and 1 sulfide. Then the only reaction that can occur from this is a single replacement, so that would make Cr S, because it says here forms a +2 ion, +2, and S is -2, so we have 1 of each, and then plus just lithium. Then we can balance this. 2 lithium on this side, so we just put a 2 here, and wait, let me do that in a different color. 2, and it should be balanced now. So Mr. Benson likes to write the values under his equation, so I'll do that too. 10.00 grams under chromium, and then the other one, 1.75 grams under the metal. What's the metal? It's lithium, because that's the metal that's produced, so 1.75 grams. Let me just draw a line under this. Okay, now what we need to do, we're looking for the percent purity of the chromium. So the important value here is the 1.75, because we don't know how much of the 10.0 grams is reacted, but we know the 1.75 grams, that's all being reacted from the reactants. So that's the more important value. So first we take 1.75 and convert it to moles. So mole ratio for lithium, or no, not mole ratio, grams per mole is 6.9 over 1 or under 1 mole. Grams cancel out. So here you need to be careful. Mole ratio, or grams per mole, can have 3, 4, or 2, maybe even 5 sig figs. So if it has 2 like it does here, your answer will be, if you just do multiplication, then it will be 2 sig figs. So your grams per mole can limit your answer. Just something to watch out for. So if we put this in our calculator, 1.75 divided by 6.9, that is 0.2536. Let's just keep some additional digits. But this is 2 sig figs, so I'll do an arrow there. Moles. And this is lithium. Let's write the element. So now, what we need to do is find how much of the chromium was reacted to make this much lithium, and then we can find the percent purity of the chromium because we already have the impure amount. So we just need to multiply this by the mole ratio. So we put lithium on the bottom, so the coefficient of lithium is 2, so we put 2 in front of Li, and then for chromium it's just 1, so 1 chromium. So we just take this value that we have and divide by 2 to find the moles of chromium that were reacted. So divide by 2 gives us 0.1268 moles of chromium, 2 sig figs. Then from here, now that we have the moles of chromium, we can find out the amount in grams that were reacted. Let's write this down again. 0.1268 moles. Then, we just need to convert this into grams so we can find out, compare it to the 10.0 grams we have. So multiply it by, chromium is 52 grams per mole. So we have 52.0 actually grams per 1 mole. And cross out moles. Okay, now let's multiply what we have in our calculator by 52. That gives us 6.5942. 2 sig figs. This is grams. Okay, now we find the percent purity. So if you didn't know, the formula is amount pure over amount impure. So if you don't really understand it, then you should memorize this formula and it'll probably help you. And amount impure is not just like the amount that isn't chromium, that isn't pure chromium, it's just the entire amount of the sample of chromium. Oh, not equals. Oops. It's times 100%. So now from this is our amount pure, because this is what was the amount of chromium that was reacted to make the lithium. So we can put that down. It's fine to round up to 2 sig figs now. 6 grams, and then the amount impure, the total amount of the sample of chromium, is 10.00 grams. 0.00 grams times 100%. Now we cancel out the grams, and then you can put this in your calculator. 6.6 divided by 10, 0.66, and then multiply that by 100, it's 66%. And that's our final answer. That's the percent purity of the chromium. Now, for the next question. Automotive airbags inflate when solid sodium azide, NaN subscript 3, decomposes explosively into its constituent elements. What volume of nitrogen gas is formed if 120 grams of 85% pure sodium azide decomposes? Assume STP conditions. So, first of all, any stoichiometry question start with a balanced reaction equation. So that would be NaN3, sodium azide, N3, it's pretty ugly, and it's just a decomposition. So this is the only reactant and decomposes into two others, which is Na and N. So Na sodium plus N. And nitrogen by itself is diatomic, so don't forget the 2 here. Now to balance it, we need to balance the ends. So if we multiply this by 2 and then this by 3, we have 2Na, 6N, on this side 1Na and 6N, so we just need to put a 2 here. Then we have 2Na on both sides. So now that we have this, this question is a lot easier than the other one, I think. This one is working the other way around. So what we do is we take the amount of Na, let's write it underneath, 120 grams. So 120 grams, what we do with this, convert it into moles. So times NaN3, let's calculate that first. So let's make a grams per mole for NaN3, molar mass. So Na is 23.0, 0.0, and plus N3, which is 3 times, N is 14.0. So if you put that into your calculator, 23 plus 3 times 14, that's 65. .0, and it's grams per mole. Okay, now we can calculate the moles of the NaN3. So 65.0 on the bottom, grams, over 1 mole. And then cancel out the grams. 120 divided by 65. Now notice right away that 120 is 2 sig figs, so this will limit our answer. 1.846, 2 sig figs, and this is moles of NaN3. Let's write that. So now that we have this, we're looking for the amount of N3, oh wait, no, N2 that is made. But first, before we find that, we need to notice that it's 85% pure sodium azide. So how do we do this? Well, 3. So to find that it is 85% pure, to find the actual sodium moles of actual sodium azide, pure sodium azide that reacted, we need to multiply this by 85% over 100%. So that's just 0.85. Multiply this by 0.85. So if you do that, 0.85, we get 1.569 moles of NaN3. So 2 sig figs. Then after we have the actual amount of pure NaN3, we can find how many moles of N2 we created. So times a mole ratio. So let's look at this. Coefficient of NaN3 is 2, and coefficient of N2 is 3. So this would be 3N2 over 2NaN3. So we can cross out the NaN3. Divide what you have in your calculator by 2 and also multiply it by 3. That would give us 2.354. This is moles of N2. And 2 sig figs. Oops. So now that we have the moles of sig figs, we need to go back to our question and see what it asks. What volume of nitrogen gas? How do we find the volume of the gas if we only have moles? Now remember, it says STP, so hopefully you memorized the formula for converting moles of gas to liters at STP. It is 22.4 liters over 1 mole. So cross out the moles, then we can find this pretty easily. Just multiply times 22.4. This is our final answer, so we can round it up to 2 sig figs, which is 53 liters. And that is our final answer. Let me know if you want part 3. Thanks.